Graphs of recurrence relations. When plotting the recurrence relation for an arithmetic sequence, you should end up with a straight line. So if these are the terms of the sequence, so these are the terms, and then you put in the value of the sequence on the y-axis, and your point should be in a straight line. Now you sometimes see people actually put a line through those. I don't agree with that because there's no meaning in between here, but you see it done, so just be aware of that. When plotting the recurrence relation for a geometric sequence, you should end up with an exponential line. That's a curved graph that either gets steeper or shallower as the terms increase. We'll look at that in a moment. When the recurrence relation is representing a geometric sequence with a common ratio between -1 and 1, the graph will appear to flatten as time progresses. A geometric sequence like this converges to 0. Now, so if we look at a geometric sequence with all positive terms, it's either going to go like this, so it's going to grow. If that one had some negative terms, they would grow down this way. So we'd get sort of a funnel effect, and the terms go positive, negative, positive, negative, positive, negative, and so on. The situation we're talking about here with -1 and 1 goes the other way. So I'll just draw that down here. So they flatten. If all the terms are positive, it flattens like this. If some of them are negative, they alternate, then you get this type of thing. And it funnels inwards towards the x-axis, so towards 0. To find the final value for a general relation, Tn plus 1 is Atn plus b, where a is between -1 and 1, that the graph will finish at, you must use the fact that long term, Tn plus 1 is equal to Tn. So what happens is, in this situation, you get a funnel situation like this one. Let's just clear those. So you get a funnel situation like that. But if this is the x-axis, and I'll just draw it for positive only terms, you get a value up here that it converges to, and not the axis. To find that, you use this. Now clearly they're never actually equal. Tn plus 1 is only ever going to be approximately equal to Tn. But the point is that the gap between them gets smaller and smaller and smaller. So if we think about n being really large, we go a long, long way along the terms, they're virtually the same. And since we're trying to find a limit, which is what happens at infinity, we can assume this in order to work out the limiting value for the curve, and we'll see how that works in the examples.